who watched the video, or I'll just say it again, but the zero product property, product means multiply, right? When you multiply, oh, this is not a good pencil. Hold on. I didn't want to use green. Here we go. So when you multiply A times B, if you get 0, then either A has to be 0 or B has to be 0, right? Because if A is 3, 3 times 0 will give me 0. So these are all in factored form. So if they're in factored form, it's easy to solve. You're asking yourself, what x value will make x minus 3 equal 0? So one of our solutions is positive 3, because 3 minus 3 will make this whole thing equal 0. So that would make this 0 and this 10. 0 times 10 is 0. So one of our solutions is x equals positive 3. And our other solution would be what? If x plus 7 has to equal 0, what does x have to be? Negative 7. So our goal is to get things into factored form so that we can figure out what x is. So if I graph this quadratic, I'm borrowing yours. If I graph this quadratic, I can put it in the format, let's see, x minus 3 times x plus 7. Where is it going to touch the x-axis? Well, it touches the x-axis at negative 7 and at positive 3. So graphically, I should get the same solution as using the zero product property. All right, let's do this one in our head. What will make this function equal 0? So you look at your two factors. What will make this factor equal 0? 10? 3? What has to be, to make this 0, x would have to be 0 itself, right? What about to make this one 0? X would have to be 5. So your two solutions are 0 or 5, or you could say 0 and 5. All right, on number 3, the only solution for this one is when x is positive 10, right? 10 minus 10. This is really x minus 10 times x minus 10. So you get the same factor twice. So what does this quadratic look like? So if I plug in x minus 10 squared, I have to adjust the window so you can see it. This quadratic is going to come down and just touch the x-axis at 10 and then bounce off again. It only has one x-intercept. So if it only has one x-intercept, the vertex is the x-intercept. All right, number 4. And then you're going to try number 5 in a minute. Number 4, this one's a little bit harder to do in your head. So you're going to take 3x plus 2 and set it equal to 0. How do I solve this equation for x? How do I get x by itself? This is your algebra 1 skills. Yes, after I solve this, you can tell them to check, but I'm afraid they'll forget. That's why I always have them solve it algebraically. So like subtract 2 to the other side. I think you know which trick you're going to show them. Divide by 3 on both sides. X equals negative 2/3. So Colin's going to tell you a trick. What's your trick? Sure. I was thinking it was a certain trick, but maybe it's something different. Maybe I'll learn something. Is it the opposite of this guy divided by this? Okay, okay, yeah. So because he's done so many of solving this for 0, he knows what is always the first step. Moving this number to the other side of the equation. And what's always the second step? Dividing by that number. So I could do that trick too. Like in my head, I know the answer is negative 2/3. But what he's doing is he's just skipping a couple of the steps and knowing I would subtract this to the other side and divide by 3. So if you're a shortcut person and you can just kind of see that, you don't have to write out the whole equation. So like, let's do the shortcut on what would this one be? This would have to be what? So this would get moved to the other side in our head. positive 1, and then what would I divide by? So positive 1/4 is the other x-intercept. But if you forget that, I just want you to be able to solve it algebraically. Write out the equation for yourself. Okay, so try number 5. This 2 out front doesn't do anything. 2 can never equal 0. If this said 2x, then one of your solutions would be that x could be 0. Ignore the 2 in the front. Tell me what x would have to be here, and tell me what x would have to be here. So what would be your 2 solutions using the zero product property? And then we'll try the ones down at the bottom. So either do the shortcut trick, or actually I like writing it out too, because then I don't make mistakes. All right, so you got either, I'm going to write it unsimplified, 2/4, or this one would be -2, right? That's 1/2, right? 1/2 or -2. Did you get that okay? Did you get that okay? Okay, so step 1, you have to be able to use the zero product property because the 4 factoring strategies, GCF, difference in squares, the trinomial, and the trinomial with the box, all 4 of these strategies rely on the zero product property. So factoring is no good if you can't get to the final answer. You've got to get to what the x values are. All right, so here was the first strategy that I showed you in the video that's on the resource pages. So if you didn't do the video, you probably want to take a picture at least of my resource pages. Yeah, so let's do that. I'm not doing that right now, but yes, we should do that before you leave for lunch so you can fill it in. I recommend watching the video because that was what you were supposed to do on the remote day. Okay, rewrite each expression by factoring out the greatest common factor. What number can go into the 4x cubed and the 16x? What is the greatest common factor? 4x. So I write the 4x and then I write a parenthesis, and now I'm going to divide both of these terms by 4x. What do I get when I divide by 4x? X squared from the first guy, and then what do I get? 16x divided by 4x is x squared plus 4. So that's my greatest common factor, and that's what I have left. And one thing I always liked about math is I could check my answer after the problem. Do you guys ever check your answer? So in my head, does 4x times x squared equal 4x cubed? Does 4x times 4 equal 16x? So if you just check your answers, you'll catch yourself from making any mistakes. Number 7 looks a little bit strange. What's the greatest common factor on number 7? A. So then I would have x plus y left, right, if I divide them both by A. All right, you try 8 and 9. See if you can figure out the greatest common factor on 8 and 9 and do it. And then we'll do 10 together, and you can try 11, 12, because you have to know these methods. So do 8 and 9 and stop. And I'm just going to put in our attendance really quick. Everything's a competition between siblings, so. Okay, number 8, you should have pulled out a 3x, and x minus 2 is left. Did you get it? Then number 9, same strategy, it's just a trinomial. I can pull out a 3 and what, an x? So now I have to divide all 3 terms by 3 and by x. So 6 divided by 3, so I'd have 2x squared. 9 divided by 3, so I'd have 3x, and then just plus 5. So for now, we're stopping here. There may be a way to take these trinomials a step further, but we don't know what that is yet. Our goal is to take out the greatest common factor. Okay, how are numbers 6, 7, 8, 9 different than 10 through 13? There's a slight difference in the directions. Now this one says, and solve. So once we have factored form, we're going to do the zero product property and actually solve for x. So let's do this first one together. What's the greatest common factor on number 10? X. This is sometimes hard for students. When I take x squared and I divide by x, what do I have left? Okay, when I take x and divide by itself, what do I have left? 1, not 0. Sometimes people say that that's gone completely, but make sure that you put a 1 because if I forget to put the 1 there, if you go x times x, you'll just have x squared. You need to do x times 1 to get back to that original x. So now it says factor and solve. What does x have to be here and what does x have to be here to make it 0? Either 0 or -1. So you actually have to finish and take it to that last step. Do you think you can try 11, 12, and 13? Factoring out the greatest common factor and solving for x. I'm going to give you like 3 or 4 minutes to try 11, 12, and 13. And then we're going to try the difference of squares. 11. You take out the 11 x's, and then you have 1 minus 2x. I saw some of you forget the 1. So when you're dividing by 11x, anything divided by itself is 1. And when you're dividing by 11x, you get -2x. So if you start with a binomial, you should end up with a binomial. You're dividing the two terms. There's an end result. You're never going to end up with 0 of something when you divide. So then x can either be 0 here, 11 times 0 is 0. I can't, most of you probably can't do this one in your head. 1 minus 2x equals 0. You can either subtract 1 to the other side or add 2x. I like to add 2x just so I'm dealing with positives. If 1 is equal to 2x, how do I solve for x? Just divide by 2 at the end. So 1/2 is your other x-intercept. I didn't leave enough room, but 0 or 1/2. Number 12 and 13, are those quadratic functions? 12 and 13, are those quadratic? What kind of functions are those? Starts with an L. They're linear. See how they just have x to the first power? So yes, I wanted you to, practice taking out 5, and you have 3x plus 4. You only have one solution because this is a line. So you're going to ask yourself, where is 3x plus 4 equal to 0? Subtract 4 to the other side and divide by 3 if you're doing the kind of shortcut, -4/3. What we've done in the past is we've just subtracted the 20 and divided by 15. You end up with the same answer. We're just practicing greatest common factor. But you can solve linear equations like this too. And you have x plus 1 left. Right? Divide out the 210, x plus 1, x must be -1 from that guy. So greatest common factor, if you're having trouble with it, you will continue to see it all week because you always look for a greatest common factor first. You don't have to flip this page, but I just wanted to show you in the grand scheme of factoring flowchart here. Guess what's always first? Step 1, don't forget to pull out the greatest common factor first. Every single time you look for a greatest common factor to start the problem. It'll make your life easier if you always do that first. All right, then the other strategy that was introduced to you yesterday, maybe in that video, is looking for a difference of squares. And I had you, if you did the video, you wrote down all the perfect squares twice because I made you do it on one page, and then I realized, oh, when you turn the page, it's on the other page. So how many of you have already taken geometry? So you should have done the Pythagorean theorem, looking for perfect squares, maybe reducing radicals in the Pythagorean theorem. Like these should be really forward in your brain numbers. Like if I see 81, I recognize that that's 9 squared. Or if I see 36, I'm recognizing that that's 6 squared. I don't have 15 in this list. I don't have 40 in this list. These are not perfect squares. Right? So knowing a perfect square is kind of like step 1. Step 2, you're looking for a minus sign. What does the word difference mean? It means subtraction. And then you're just taking the square root of each of the terms. So number 14 would be x plus 3 and x minus 3. And let's just see if this works. X times x, if I did FOIL or box method, would give me back my x squared. 3 times negative 3 gives me the negative 9. And what happens in the box or FOIL, your outer and your inner come out opposite. Positive 3x and negative 3x. What does positive 3x plus negative 3x add up to? No x's. Do you see any x term up here? No, you just have x squared and a constant. You have 0x term. So the reason difference of squares works is because you only have a first and a last. How would I factor, question? How would I factor 15? Take the square root of each part. So x squared is always x times x. What's the square root of 49? 7. So plus 7 and minus 7. Difference of squares should be like really quick and easy if you know your perfect squares. All right, 16 has a coefficient in front of the x squared. Well, what times what would give me 4? 4 is what squared? Square root. So 2x times 2x. And what's the square root of 25? 5. So 2x plus 5, 2x minus 5. What do we call something when it's not factorable? Did anyone catch that from the video? It starts with a P. Prime. Do you know some of the prime numbers? Prime number. 12 is not prime. It's not a perfect square, but it's also not prime. 7 is a prime number. It's any number whose only factors are 1 in itself. 13 is a prime number. 17 is a prime number. 19 is a prime number. So prime means numbers that are not factorable and also quadratic. Technically, the first prime number is 2 because 2 in itself, 2 and 1 are its own factors. I don't know why, but 1 is not considered a prime number. But what? 1's a perfect square. Yeah, but I don't know why 1 is not a prime number, but it's supposed to be, it only has the products of itself and 1. Okay, so after lunch, we'll try 18 through 21 to wrap up this page, and we're going to learn a slightly new strategy. Can I see show of hands? Have you guys done the diamond puzzle before? Did I copy a diamond puzzle on one of these pages? Oh, I hope I did. Does a diamond puzzle sound familiar? Like, have you ever filled in a diamond puzzle before in Algebra 1? Oh, good. You know what this is, baby. Multiply and add. Okay. Yeah, good. I'm hoping you've seen it before. Time. Nope. Why is 21 prime? Plus sign, it's not a difference of squares. So you can say that it is prime and there's no solution. It will never have any x-intercepts hovering 100 units above the x-axis, right? If I shift it up 100 units and it's concave up, will I have any x-intercepts? No. Okay, 256 and 361. Those are 16 and 19 up in my chart. So let's work backwards here. So 256, I wouldn't necessarily know myself. 16x times 16x. 361 is 19 squared. Plus 19 minus 19 equals 0. So what am I going to do to solve these? Well, first of all, I'm going to get the same answer to both of the parentheses. They're just going to differ by a minus sign, right? Because if I add 19 and divide by 16, 19 over 16 is the answer, right? So I would either get, for this one, positive 19 over 16, but for this one, negative 19 over 16. Because we add the 19 to the other side and divide by 16. Okay, you solve 18 and 19. Same way. Difference of squares. See if you can solve it, and then we're going to go on to the diamond puzzle. So take one more minute. Try it. Write it out. You know that it's two parentheses. You know that you're taking the square root of each part. What is the square root of 16? What is the square root of 81? Those are the numbers that go inside. So this one should be x plus 1, x minus 1, right? The square root of x, the square root of 1. And this would be 4x plus 9 and 4x minus 9. So now you see if you can get to the last step. What is x in each of those? So what are the two answers from part 1? And what are the two answers from part 2? This one's easy, right? X equals 1 or negative 1. And then on number 19, you would add the 9 to the other side and divide by 4. And sometimes you'll see an answer written like this, plus or minus 9/4. That means that one of them is at positive 9/4 and the other one is at negative 9/4. If you don't like the number 9/4, it's just 2 1/4, right? 9/4. You guys familiar with, we call it improper fraction, but it's the same as 2 1/4, right? Because 4 goes into 9 twice with 1 left over. I would know where that is on a number line, right? Where is 9/4? But where is 2 1/4? My x-intercept is right there. So sometimes it helps to put it into a non-improper fraction. Okay, diamond puzzle. Here, we're just going to do the top half today, and maybe we can do the bottom half tomorrow so that it's not too painstakingly long. Take a look at page 303. Just do the ones with the x's at the top, 1 through 16. Don't do the ones with the squares at the bottom. So your goal is that at the top, they need to multiply by each other. So 10 times 7 is 70. On the bottom, it's the sum. 10 plus 7 is 17. That's all you do. So the top multiplies. So the top is the multiplying. The bottom is the adding. Yeah, there's a couple that you'll have to problem solve the missing piece. So number 2, 8 times 1 is 8. 8 plus 1 is 9. Let's do one of the ones with a negative. 5 times negative 4 is how much? Negative 20. And what is 5 minus 4? Positive 1. So take a minute and see if you can just do 1 through 16. Those are the only ones I'm going over. If you feel like going further, go for it, but we're going to do the rest another day. So 1 through 16, page 303. This is our strategy. It's going to help us factor in a minute. So you can do a solid on this, called a diamond puzzle. I'm just going to take mine of what goes on the bottom. So, did you kind of get them? So 78, negative 27, 17, 9, 1, and 8, 72, negative 20, negative 12, 18, 18, 8, 1, and 9. Then the top is 24, 36, negative 50, 11. And the sides were 3, 3, negative 5, and 11. And then let's see. This one needed the 11 and the 19. This one needed a 40 and a 10, an 8 and a negative 4, a 1 and a 5. So you did that okay? That's familiar to you? That's how you're going to solve these factoring problems. So you do not have homework tonight on this new stuff. The homework tonight, 3-2, is only on greatest common factor and difference of squares. So we're going to spend another day working on these trinomials. Flowchart, right? The flowchart that you could reference. All right, what do? I pull out the greatest common factor. Now, do I have a difference of squares? Maybe I have 2 terms. Maybe I have 3 terms. So now I'm down here. 3 terms is what we're going to learn today. So page 3-5 is the resource page. Oh, don't forget, some of you are going to take a picture of 3-3 and 3-4 before you leave, or you could use the video. No, we're going to do some practice problems of this in a minute. I'm not going to go back. We already did it in the video from yesterday. So, steps. So you first recognizing that you have 3 terms, there's no greatest common factor, and it's in standard form. So now you write your 2 parentheses and you put an X in each one. So I should play you teach me how to factor. Maybe tomorrow I will. Set up 2 terms, put an X in each. Minus here, plus there. Listen when I teach. So there's a whole rhyme about this. But now you're going to set up your diamond. You are going to put negative 12 at the top of your diamond, which is coming from this guy, and your B term goes on the bottom. This is really A times C, but in this case, oh, you can't really see this very well. I'm going to put my, I'm going to turn the light off, or focus down. So your C term, I just put it up here, but it's nice to know that this is a 1x squared. So negative 12 goes on top, 1 goes on the bottom, and then you complete your diamond puzzle. This is the hard part. You're looking for the factors of negative 12 that add up to 1. So what are the factors of 12? 1 times 12, 2 times 6. Yep, so 1 times 12, 2 times 6, 3 times 4. If this is negative, one of them has to be negative, and they have to differ by 1. So you know it's going to be 3 and 4, and how do you know which one is negative? So negative 3 plus 4 gives you the one that you need at the bottom of the diamond. So this negative 3 and this 4 are the factors that you're looking for. Because when you do x times x, you get x squared. Negative 3 times 4, you get negative 12. And then your outer is 4x, and your inner is negative 3x, and that adds up to 1x. Does this seem familiar at all to you? Like you hopefully learned this in Algebra 1B? Okay, I set up 2 terms. I put an x in each. If you can do it without the diamond, go for it. If you like to set up the diamond, go for that. The 1 goes on top and the negative 2 goes on the bottom. I'm looking for the factors of 1. What times what is positive 1? And it has to add up to negative 2. Yeah, negative 1, negative 1. X minus 1, x minus 1. I wrote a note at the very bottom. B and D are called perfect squared trinomials. You might see this written x minus 1 squared on like the SAT multiple choice. Those are equivalent statements. We know that anyway. But so perfect square trinomial because you get the same term twice. All right, C and D. They want you to factor and solve this time. So you set up 2 terms, put an x in each. Now you do your diamond of your 32 and your 12. So you're looking for the factors that multiply the 32 that add up to 12. This is where your mental math skills are really important, but if you get really stuck on this, set up a chart on your paper. Okay, I know that 1 times 32 is 32. I know that 2 times 16 is 32. Let's see, is it divisible by 3? So on your calculator, you divide it by 3, it's not. Okay, is it divisible by 4? So on your calculator, you do 32 divided by 4, and yes, it's 4 times 8. 5 doesn't go in evenly, 6, 7. So those are my choices. I'm looking for either add up or have a difference of 12. So do you see how it's 4 and 8? So if you get stuck, take your calculator. Is that what you were going to say, the answer? But I'm stuck. Start writing numbers out on your calculator. So x plus 4, x plus 8. What are my two solutions? 4 and 8 are my factors. Negative 4 and negative 8 are my actual x-intercepts. So make sure that you actually try to solve the final equation. Okay, so the last example was add up 2 times an x in each. Maybe I will play you the song just so you don't think I'm crazy. Okay, so now you're looking for the factors of 16 that add up to negative 8. So there's got to be some negatives going on in there. What times what is positive 16? Negative 4 times negative 4. So you might write that as x minus 4 squared if you're factoring it. You're looking for what does x actually equal. What is the actual x-intercept? Positive 4, right? Okay. So while you are flipping the page, I know we're doing a lot of flipping here. Let's see, greatest common factor, difference of squares. I want you to skip down to page, back to that diamond puzzle, 303. The last practice problems for today are the bottom of the page. Skip the top of the page because we spent a lot of time on difference of squares before lunch. Does anyone hate when they use a variable other than x? Yeah, they're using like a, they're using c. Page 303 in the back. I get annoyed by it, but it's going to help you practice for how the SAT formats problems. So, I mean, use x. If you want to use x on all of them, but you're really, it's just a variable, right? Yep. So you need to take a picture of my page. Okay, so does everybody see where we are? 13 through 20 are the last problems that I want you to do today, and then I'm going to play you teach me how to factor. Does anybody need like more help than that? Do you think you can tackle 13 through 20? They're all diamond problems. I think they all work. So none of them do not have a solution. Okay, so you're trying. These are the answers you should have gotten for 13 through 20.